Assalamu alaikum. My name is Jibran Khan, currently studying mechatronics in AI University Islamabad. I'm a student of first semester and my class section is C. Today we will be discussing about 20 daily life components used in electrical engineering. The components we will discuss are the following mentioned on the screen. Now the first component that we will be discussing is the thin film resistor array. Array are offered in 3 to 12 resistor combinations. All resistors are the same value and tolerance. They feature excellent resistance ratio tracking and are of optimum use when space is a premium. Thin film resistors are a type of resistor that possesses a thin resistive layer set on top of a ceramic base. The principal difference between thick and thin resistors is the thickness of the resistive layer, with thin film possessing a thickness is of around 0.1 microns. Now, the second one is the wire-wound potentiometer. Wire-wound potentiometer comprises of several rounds of wire wound around the shaft of the non-conducting material. The turns of the coil are bonded together by an adhesive. In this case, the slider connected to the body whose displacement is to be measured moves on the potentiometer track, and it makes contact with successive turns of the coil. In this case, the wire between the two successive turns is not covered by the slider, which limits the resolution of the wire-wound potentiometers. However, the larger the number of turns of the coil, more is the resolution of the coil. The resolution is measured as the reciprocal of the number of turns of the coil. Now, the advantages of this potentiometer is high power, high heat tolerance, very long life, and low noise. Now the one that we have now is the tremor potentiometers. Tremor potentiometers, sometimes referred to as trem pots or tremor resistors, are a type of adjustable potentiometer. They are used to calibrate and fine-tune circuits. Tremor potentiometers are typically constructed from cermet or have a high carbon composition. They can be mounted directly onto PCBs printed circuit boards. Tremor potentiometers are not adjusted very frequently. You can think of them as a set and forget component. Trim parts let you set or trim the resistance to obtain a very precise current, output voltage or gain. Once the value has been set, it is unlikely that you will need to adjust the trimmer again unless you need to recalibrate the circuit. The adjustment types are trimmer potentiometer are normally adjusted by hand. You can turn the adjustment knob with your fingers, with a screwdriver, or with a specialized adjustment tool designed for use with a particular model or series. Now we have the 15-turn potentiometer. 15-turn potentiometer is a type of variable resistor that allows for precise adjustment of resistance over a range of values. Unlike standard potentiometers that may only rotate 270 degrees or so, a 15-turn potentiometer requires 15 full rotations to move from one end of its resistance range to the other. The extended rotation provides finer control, making it useful in application where precision is important, such as in audio equipment, scientific instruments, and calibration tasks. The key features of it are precision, allows for detailed adjustment. Number 2 is the resistance range, offers a specific range of resistance value which can vary by model. Number 3 is the form factor, usually found in a compact, durable design suitable for various applications. The applications are audio mixing and control, laboratory equipment calibration, robotics and control system, custom electronics projects. Now centrally here it is constructed by usually have a wiper, the moving contact that slides along the resistive track. Number 2 is the resistive element, which is made from material like carbon, cermet or metal fin, which determines the resistance value. Number 3 is the housing. Housing typically encased in a durable material to protect the internal components. Number 4 is the shaft. The part you turn, it has a gearbox to allow for multiple turns. It has two types. Number 1 is the linear potentiometer. Resistance changes linearly with the rotation of the shaft. Number 2 is the logarithmic potentiometer. Resistance changes logarithmically, often used in audio application to match human hearing perception. The advantages of 15-turn potentiometers are the precision control, The 15 ton allows for very fine adjustment, ideal for calibration. Number 2 is the stability, often designed for long-term use without drifting, maintaining accuracy over time. Number 3 is the durability, typically built to withstand frequent adjustment. The common applications of it are audio equipment, used in mixers and volume controls to achieve precise sound adjustment. Number 2 is the measurement devices, employed in voltmeters and other instruments where exact rotation values are crucial. Number 3 is the robotics, in feedback systems for controlling motor positions. Number 4 is the custom electronics, useful in DIY projects requiring precise tuning such as oscillators or filters. Now we have 10-ton potentiometer. A 10-ton potentiometer is similar to a 15-ton potentiometer, but requires only 10 full rotations to cover its entire resistance range. This design offers a balance between precision and ease of use, making it suitable for various applications. The key features of it are precision adjustment, provides fine control over resistance changes ideal for applications requiring accurate tuning. Resistance range, commonly available in a variety of resistance values. Number 3 is durability, typically built to withstand numerous adjustments, making them reliable for long-term use. We have two types of potentiometer: linear potentiometer, logarithmic potentiometer. Linear potentiometer resistance changes uniformly with the turn of the shaft. Logarithmic potentiometer resistance changes logarithmically, used in audio applications where the perception of sound is non-linear. The advantages of it are fine control. The 10-ton allow for precise adjustment, making them suitable for applications where small changes can have significant effects. Number 2, it is user-friendly, easier to use than higher ton parts while still providing good resolution. Number 3 is the versatility, suitable for a wide range of applications from audio controls to instrumentation. Now on your screen is a ceramic disc capacitor. A ceramic disc capacitor is a type of capacitor that uses a ceramic materials as its dielectric. These capacitors are widely used in various electronic applications due to their reliability, stability, and relatively low cost. The key features of it is construction. Construction consists of a ceramic dielectrical layer sandwiched between two conductive plates. The dielectric is typically made from materials like barium titanate. Number 2 is the capacitance range, available in a wide range of capacitance values, usually from a few picofarads to several microfarads. Number 3 is the voltage rating, commonly found in voltage rating from a few volts up to several kilowatts. Now we have its types. Number 1 is class 1 ceramic capacitors. They have stable capacitance with temperature variation and are suitable for precision application. Number 2 is class 2 ceramic capacitors. These offer high capacitance value but can have more variations with temperature and voltage. The advantages of it are as following. Number 1 is the temperature stability. Class 1 capacitor maintain capacitance better across temperature changes. Number 2 is low loss. They exhibit low equivalent series resistance, making them ideal for high frequency application. Number 3 is the size, typically compact, allowing for space-saving designs in electronic circuits. Number 4 is the durability, resistance to moisture and mechanical stress, making them suitable for harsh environments. Now we have the glass capacitor. A glass capacitor is a type of capacitor that uses glass as its dielectrical material. These capacitors are known for their stability, reliability, and ability to perform well in a wide range of environmental conditions. Its key features are dielectrical material. Glass serves as the insulating layer between the conductive plates, providing excellent electrical properties. Number 2 is the capacitance range, typically available in lower capacitance values, often in picofarad to microfarad range. Number 3 is the voltage ratings, can handle high voltage applications, making them suitable for power electronics and RF circuits. Its advantages are high stability, low loss, chemical resistance, non-polarity. In high stability, glass capacitors exhibit excellent temperature and voltage stability, ensuring consistent performance over time. Number second, low loss. They generally have low equivalent series resistance, making them ideal for high frequency application. Number third is the chemical resistance. Glass is resistant to moisture and corrosive environments, enhancing the lifespan of the capacitor. Number four, non-polarity. They are typically non-polarized, allowing for versatile applications in various circuits. A multi-layer ceramic capacitor. A multi-layer ceramic capacitor is a type of capacitor that consists of multiple layers of ceramic dielectrical material interleaved with conductive electrodes. This construction allows for high capacitance value in a compact form factor, making these popular in various electronic applications. Its key features are composed of numerous thin layers of ceramic and metal electrodes stacked together to increase capacitance. It is available in a wide range from few picofarads to several microfarads. It is typically ranging from a few volts to several hundred volts, with some high voltage variants available. It has two types. One is class 1 and second is class 2. Class 1 provides stable capacitance with minimal temperature and voltage dependency. Class 2 offer higher capacitance values but have greater variation with temperature and voltage. Its advantages are their high capacitance density. The multi-layer designs allow for significant capacitance in a small package. Number 2 is the low equivalent series resistance, ideal for high range frequency applications. Number 3 is the temperature stability. Class 1 MLCs maintain their capacitance over a wide range of temperature, while Class 2 types can provide good performance in varying conditions. Number 4 is the non-polarized. It is non-polarized and can be connected either direction, simplifying circuit design. Aluminum electrolyte capacitor. An aluminum electrolyte capacitor is a type of capacitor that uses an electrolyte solution to achieve high capacitance values. These capacitors are widely used in various electronic applications due to their ability to store significant amounts of energy in a relatively small size. It is comprised of an aluminum foil anode, a dielectric oxide layer, and an electrolyte, liquid or solid, that serves as the cathode. It is generally available from microfarads to several thousand microfarads. It is commonly found in voltage ranging from few volts to several hundred volts. It is two types: polarized capacitors, non-polarized capacitors. Polarized capacitors, typically aluminum electrolytic capacitors, are polarized, meaning they have a positive and a negative terminal. They must be connected correctly in a circuit. Non-polarized capacitors are less common but available for AC applications. Its advantages: it has high capacitance density. They can achieve high capacitance values relative to their size. And it is cost effective. Generally, aluminum electrolyte capacitors are less expensive compared to other high capacitance options. Now we have the film capacitor. A film capacitor is a type of capacitor that uses a thin plastic film as a dielectrical material. These capacitors are known for their stability, reliability, and wide range of applications in electronic circuits. They are composed of a thin layer of dielectrical film such as polyester, polypropylene, or polycarbonate sandwiched between two conductive electrodes. They are typically available from a few picofarads to several microfarads, available in a variety of voltage ratings, often ranging from a few volts to several hundred volts. It has four types. Number 1 is the commonly used for general purpose applications. Number 2, the propylene capacitor, known for better electrical properties and often used in audio application. Polystyrene capacitors, often high precision and stability, used in timing and RF applications. Number 4 is the metallized film capacitor. Feature a metal layer that serves as one of the electrodes, providing better self-healing properties. It is many advantages. Number 1 is stability, excellent temperature and voltage stability, making them suitable for precision applications. Number 2 is low loss. Low equivalent series resistance and low dielectrical loss is ideal for high frequency application. Number 3 is the durability, typically robust and resistant to environmental factors such as moisture and temperature fluctuations. Number 4 is the non-polarized. It is non-polarized, can be connected in either direction, simplifying circuit design. Now we have a dipped tantalum capacitor. A dipped tantalum capacitor is a type of tantalum capacitor that is coated with a protective layer, often using a dipping process. These capacitors are known for their high capacitance values in a small size and are widely used in various electronic applications. It is comprised of tantalum metal anode, an oxide dielectrical layer, and a cathode, usually manganese dioxide or conductive polymer. It is typically from a few microfarads to several hundred microfarads, commonly found with voltage ranging from a few volts up to several hundred volts. It has high capacitance density, can provide a high capacitance in a compact form factor. It has good temperature stability and reliability, particularly under varying environmental conditions, suitable for high-frequency application due to low ESR. It has a self-healing property. If a dielectrical breakdown occurs, the oxide layer can repair itself, preventing catastrophic failure. Now we have polymer tantalum chip capacitor. Polymer tantalum chip capacitor are a type of capacitor that combines tantalum high capacitance with a polymer electrolyte. They are known for their high stability, low equivalent series resistance, and reliability. They can achieve high capacitance values in small packages, making them suitable for space-constrained application. The characteristics improves performance in high-frequency application, making them ideal for power supply, decoupling, and filtering. Polymer tantalum capacitors often have better performance over temperature ranges compared to traditional tantalum capacitors. The polymer electrolyte typically has lower leakage current than liquid electrolytes. They are used in smartphones, tablets, and other portable devices. They are often found in motherboards, graphic cards, and power management circuits. They are also used in base stations and networking equipment. Polymer aluminum chip capacitor. They are another type of capacitor that utilizes aluminum as the anode material and a conductive polymer as the electrolyte. They combine some of the advantages of both aluminum electrolytic capacitors and solid polymer technology. The polymer aluminum capacitors have lower ESR, low equivalent series, than traditional aluminum electrolytics, making them suitable for high-frequency applications. They can handle higher ripple currents, which is beneficial in current power supply circuits. These capacitors are available in small sizes, ideal for space-constrained applications. They have longer lifespan, tends to enhance reliability, longevity compared to liquid electrolytes. They are commonly used in smartphones, tablets, and laptops for decoupling and filtering, ideal for input and output smoothing in DC converter and power management modules. They are used in automotive electronics for power supply and signal processing. Axial inductor. An axial inductor is a type of inductor characterized by its cylindrical shape and a long, narrow body. Unlike traditional toroidal or radial inductors, axial inductors have leads on either end, allowing them to be monitored directly onto printed circuit boards in a linear configuration. They are typically made by winding wire around a magnetic core, which enhances inductance. The axial design is space efficient, making it suitable for applications where height is constrained. It is available in a wide range of inductance values suitable for various applications. The axial leads make them easy to solder directly onto PCBs. They can fit into compact spaces, which is important in modern electronic designs. They offer stable inductance values with minimal losses, especially at higher frequencies. They are commonly used in power supply circuits for filtering out high-frequency noise. They are utilized in applications like DC converters where energy storage is required. They are used in tuning circuits in high-frequency applications for tuning and impedance matching. For using this, always check the current rating to avoid saturation or overheating. Ensure that the inductance value is appropriate for the intended application. Consider the operating temperature range specified by the manufacturer. Surface mount inductors. Surface mount inductors are compact inductive components designed for surface mount technology. They are used to store energy in a magnetic field when an electronic circuit passes through them. They are designed for small footprints, making them ideal for space-constrained applications. They are soldered directly onto the surface of PCBs, eliminating the need for through-hole mounting. They are available in a wide range of inductance values to suit different circuit requirements. Their small size contributes to low overall device height crucial for modern electronics. They are compatible with automatic assembly processes, improving manufacturing. The design minimizes stray inductance and capacitance, enhancing performance in high-frequency applications. They are commonly used in DC-DC converters, voltage regulators, and power management circuits. They are employed in filtering applications to suppress noise in various electronic devices. They are used in radio frequency applications for impedance matching and tuning circuits. For using it, check the maximum current rating to prevent saturation and overheating. Ensure the selected value fits the specific application needs. A lower DCR is desirable to minimize power losses. Verify that the inductor operates within the specified temperature range for reliability. Now we have sintered ferrite inductor. Sintered ferrite inductors are inductive components made from ferrite materials. They have undergone a sintering process. Ferrite is a ceramic compound composed of iron oxide mixed with other metallic elements, which gives it unique magnetic properties. They are made from a mixture of iron oxide and other metal oxides like manganese, zinc, or nickel. They are processed and heated to form a solid structure. Available in various configurations including toroidal, rectangular, and cylindrical shapes. The magnetic properties of ferrite allow for high inductance with low losses, making them suitable for high-frequency applications. Sintered ferrite inductors can achieve high inductance values in smaller packages, which is beneficial for space-constrained designs. They typically have good thermal characteristics, maintaining performance over a wide range of temperature. They are widely used in DC converters, voltage regulators, and other power management systems, and commonly employed in radio frequency circuits for filtering and impedance matching. They are used in audio and communication devices for filtering and signal conditioning. So for using it, be mindful of the saturation current rating to prevent performance degradation. Lower DCR is preferable to minimize power losses during operation. Ensure the inductor is suitable for the intended frequency range of the application. Ferrite materials can be brittle, so care should be taken during handling and assembling. So the overall view of it is that sintered ferrite inductors are valued for their high efficiency and compactness, making them an essential choice in many modern electronic applications. Ferrite bead. A ferrite bead is a passive electronic component designed to suppress high-frequency noise in electrical circuits. It consists of a small piece of ferrite material that is typically shaped like a cylinder or a toroid. It is made from a ferrite, a ceramic compound composed of iron oxide and other metal oxides which has high magnetic permeability. It provides high impedance to high-frequency signals while allowing low-frequency signals to pass through with minimal loss. They usually are available in surface mount and through-hole designs suitable for various PCB layouts. They are effective at reducing electromagnetic interference and radio frequency interference in circuits. They are small, lightweight, making them ideal for space-constrained designs. They are easy to integrate into existing circuits, typically placed in series with the signal line or across the power supply. They are used to filter out high-frequency noises in DC converters and power management circuits. They are commonly employed in USB, HDMI, and other data transmission lines to ensure signal integrity. They are utilized in radio, television, and other devices to reduce and improve performances. So for using it, different ferrite beads are optimized for specific frequency ranges. Choose one that fits the application needs. Ensure the bead can be handled the required current without overheating or saturating. Check the impedance profile over the relevant frequency range to ensure effective noise suppression. A 3-terminal filter capacitor. A 3-terminal filtered capacitor, often referred to as a capacitor with a built-in filter, is a type of capacitor designed to provide both capacitance and noise filtering in electronic circuits. This configuration typically includes two main capacitance elements and a third terminal that serves as a specific function such as grounding or providing a reference point. The three terminals typically consist of two for the capacitor, positive and negative, and a third terminal for a filtered output or ground connection. They often include an internal filter such as inductor or additional capacitance that helps suppress high-frequency noise. They are designed to save space on the PCB while providing both capacitance and filtering. They help in reducing electromagnetic interference and radio frequency interference in power supply lines and signal paths. They combine multiple functions into a single component, simplifying circuit design and reducing component count. They are suitable for a wide range of applications including power supplies, signal conditioning, and decoupling circuits. They are commonly used in DC converters, and voltage regulators to stabilize output and reduce noise. They are employed in audio, video, and communication systems to filter out unwanted high-frequency noise. They are used in various consumer devices such as smartphones and computers to enhance performance and reliability. So, for using it, ensure that the capacitor meets the required voltage specification for the application. Select an appropriate capacitance value based on the filtering and decoupling requirements. Check the operating temperature range to ensure reliability in specific environments. So overall, the three terminal filter capacitors are effective components for managing noise in electronic circuits, offering a compact and efficient solution for modern applications. A toroidal transformer. A toroidal transformer is a type of transformer with circular or donut-shaped core, typically made of magnetic material. This design provides several advantages over traditional laminated transformers. The core is a continuous ring which minimizes magnetic flux leakage and improves efficiency. The wire windings are uniformly distributed around the core, providing a more balanced magnetic field. The toroidal shape allows for a smaller footprint compared to traditional transformers with similar power ratings. Advantages of it are that the toroidal transformers typically have lower losses due to reduced stray magnetic fields and better core utilization. The design minimizes electromagnetic interference, making them suitable for sensitive applications. Generally, lighter than equivalent laminated transformers, which can be advantageous in portable devices. They operate more quietly, generating less hum compared to traditional transformers. They are commonly used in audio equipment, power amplifiers, and other high fidelity applications for improved performance. Found in various devices where space is limited and efficiency is crucial. Used in machinery and automation systems that require reliable power conversion. For using, toroidal transformers can be more expensive to manufacture than traditional transformers due to their design and materials. The circular shape may require specific mounting techniques to ensure stability and safety. While they are efficient, it's still important to consider the heat dissipation in high power applications. So toroidal transformers are an excellent choice for applications requiring high frequency, efficiency, low noise, and compact design. Now the last component from all the 20 components is the power supply transformer. A power supply transformer is a type of transformer specifically designed to convert electrical energy from one voltage level to another for use in power supply circuits. It plays a crucial role in ensuring that electronic devices receive the appropriate voltage and current levels. They convert high voltage AC power from the main supply to a lower voltage supply suitable for powering electronic devices. They provide electrical isolation between the primary and secondary windings, enhancing safety and reducing noise. Typically consist of two or more coils, primary and secondary, wound around a magnetic core. It has four types. Number one is the step-down transformer, reduces voltage from a high level to a low level. Step up increases voltage from a lower level to a higher level. Isolation transformer used to isolate circuits for safety, providing the same voltage level but with electrical separation. Toroidal transformer is compact and efficient option with a circular core, reducing electromagnetic interference and physical footprint. So this is the end of the presentation. Thank you all for your attention today. We've explored several key components essential for modern electronics. Each of these components play a critical role in ensuring the efficiency, reliability, and performance of electronic systems. As we move forward in our design and innovation, it's vital to understand not just how these components work, but also how they can be integrated effectively into our projects. If you have any question or would like to discuss any other topic, please feel free to reach out. Thank you once again, and I look forward to a continued collaboration. Thank you so much.